Hello. Let's have a talk today about my machine learning experience. And yeah, a few things about myself. I actually have a very strong background in Oracle development tools, and I was working with Oracle for a long time. But then, from around 2018, I decided to switch, and I decided to stop working with Oracle completely and move to machine learning. And yeah, I decided to move. There are two types of machine learning you should know. The first one is academic, where you build and design and develop uh, new algorithms, new functions, and so on. And there's another type which is industrial applied machine learning. So I decided to move to this second part of machine learning, which is applied. And in applied machine learning, you would use existing libraries like TensorFlow, Keras, PyTorch, and your job is to use API of these libraries and build models, train models with the data, and then run these models in production. So yeah, a lot of very often when developers, like web developers like myself, think that okay, let's go to machine learning and let's do some science. So in practice, there are not much science in applied machine learning because you are going to use most of the time existing libraries, existing solutions, and your job as a developer is when you work with ML is similar like you do web development. You just use different API, right? This API probably is more complex than web development API, but still it's API. Of course, you need to have additional skills. You need to be able to understand the data structure, to process the data, and make sense of the data. And you should be able to make sure that the model trains well, it doesn't overfit, and so on and so on. But at the end of the day, it's API usage. It's not that you would invent something new, like new equations or whatever. This is part of academic machine learning, and this is where you need a lot of math, right? And if you, like myself, actually going into the applied machine learning, you need some math, but it's not tremendous. You can go along quite well and without any issues. So yeah, I had this solid background in Oracle, and then I decided just to drop and go to completely new field. And why I decided so, it's back in 2018, is because I thought, let's do something new, right? Let's move to somewhere else, because kind of was becoming kind of boring to build this like a create, read, update, delete forms and UIs for the web. I thought let's do some more exciting stuff. And I was looking then like what I could do else. And then I thought machine learning is a great option because the field itself is very vast, it's huge, and there are lots of options, lots of possibilities. You can build different logic and so on. And then I thought let's implement a product. Let's do our own product called Katana. And the idea was that our product should help to automate business rules, because I'm coming from the enterprise from Oracle, and I saw a lot of use cases where like business rules automation would be useful. This is why I came up with this idea. And I'll talk about it later if it was successful or not, or what I would change if I would start now. And let's talk about skills that you need for machine learning. So as I mentioned, that there are mainly two types of ML: academic and applied. And I work with applied one, and for applied track, you need solid developer skills. So if you are a strong web developer or backend developer, then I'm sure you'll be successful with ML too, because you need similar kind of skills to be successful with ML in applied way. And another thing is you should not think that ML is some kind of sort of magic, like artificial intelligence or whatever. It's just a set of algorithms that helps automatically to identify certain patterns from the data. once it able to identify patterns, it builds some sort of model like metadata, if to talk on very abstract way. And then based on this metadata, when new information is coming, when new data is coming to the system, it's able to process that information based on the patterns that it learned. So if next would come some data which was not observed during the training, it would not be able to process it. So there's no really intelligence to it. It's just this smart algorithm which able to extract hidden patterns from the data, and based on those patterns that it learns, it can process new data which is similar to the one which was used for training. And the good thing for the software developers is that model creation, model construction in ML is probably not more than 20% of work. So 80% of work when you do ML implementations are related to data processing, data preparation, then microservice implementation, inference, and production support, and the things like what you do when new data is coming. Do you need to retrain the model or not, and so on and so on. So there's a lot of business logic around the model. So model itself you build, it's fine, you create it, it runs, but model itself is useless without all the infrastructure. And to build this infrastructure, you need a lot of skills and a lot of time and a lot of effort. And this is where I believe this is the key part of work that you would do when you work with ML, the infrastructure part, not the model training. Because another thing to keep in mind with model training, it's kind of the models are transferable from one problem to another. So if you build a model that, for example, is processing some tabular data and extracting certain rules, then 99% you'd be able to apply this model for another problem and another problem and so on. If you have a model that is doing like image processing and identifying objects in that image, then 99% you'll be able to apply that model for another problem as well. So this means as soon as you build a model, you can apply it elsewhere. And this is why the infrastructure development, UI as well, it takes a huge part of time and effort when you build machine learning solutions. So it's when you build ML, it's not only about model construction. MLOps is a key thing, and you need to invest into that and to make sure that the solution is successful. Otherwise, machine learning model is useless. Okay, and finally, what I would do differently if I would start with machine learning today. So back in 2018, when I started, first I thought, let's look into this tabular data and let's extract rules. For example, maybe you have information about invoices, right? And you would try to identify which invoice kind of is risky because payment is delayed and depends on the customer to which this invoice is issued. You would check how trustful is this customer, and based on that, you would detect and report to the accounting certain invoices that are in risk and they need to follow up for payment, for example. And there are multiple use cases like that with data. There are different business rules and so on. Initially, I thought this would be a great opportunity for ML, but after a few years, I actually find out that, yeah, it's exciting, but on the other hand, it doesn't bring lots of value to the end customers, because you could still build, obviously, business rules just with plain programming language, just code by yourself, like with if statements and different checks. So machine learning can build a model which learns the rules based on data. It's great, but on the other hand, it can be overwhelming because it's not obvious how this model learns the rules and if all the rules will be correctly processed afterwards and so on. So when you need to have the strict checks, it's better maybe to follow just to use Java, JavaScript, whatever, any programming language, and implement these rules, not without machine learning. And today, I think that it makes sense to start with machine learning from more complex solutions where it's not so obvious to implement by yourself algorithms logic like image processing, video stream processing, sound processing, and different things like automated data extraction from documents and so on. So everywhere where it's not obvious how you would do it if you would need to write a function by yourself. So this is where key machine learning strength comes. Not to replace the logic that you could code by yourself, but the strength is where you could code, you could implement something which you could not code by yourself. So this is where you should look for. Yeah, and hopefully this was useful for you. This introduction and perspective from a software developer point of view about machine learning. Thanks, and see you next time. Bye.